Okay, this is an exciting day. I just gotten delivery of some first parts for my next big project, and I am unreasonably excited about what's inside this package. So let's open it up. Oh, yes. Look at that. Look at that. Oh. Yeah. This is beautiful. Look at that. Some 2040 aluminium extrusion. Oh, it's so beautiful. It's so pretty. I don't know if it's normal to get this excited about aluminium. I don't think people are supposed to get this excited about aluminium, but I am so excited about this. So what am I going to make with this, you might ask? Well, that is going to have to be kept a secret for a little while. Well, actually, by the time you watch this, you'll see the title of the video, so you know exactly what it's for. Anyway. We are out in my tiny workshop. You guys have already seen the extruded aluminium that I've gotten for the mini CNC project. So as part of that, I also bought a new drill press. It's a new drill press. I didn't own one before, so I bought a drill press. It's not a super good one, but kind of needed for this project. I mean, it's not strictly necessary, but it will make light work of a lot of the drilling that I have to do, and it'll be more precise than doing it by hand. So I'm gonna let you guys watch me putting it together now. God knows I did. God knows I did. In the valley, all day long. God knows I did. God knows I did. Okay, so this part of the assembly is actually kind of interesting, so I said I'd jump out of time lapse just to talk about it very quickly. So the final critical part of the assembly for this is fitting the drill chuck onto the spindle. So what might seem counterintuitive when you go to assemble one of these things is that there isn't actually any mechanical fixture that holds them together. It's actually purely a friction fit. And that's thanks to a specific angle that's machined onto this taper, which is called a Morse Taper. So it's kind of hard to see, but the inside of the drill chuck is actually tapered. You can kind of see there the difference. You can see straight through there, and you can see the innards there. And the taper that's on that matches the taper on the end of the spindle shaft. So the whole spindle assembly is all in here, on all of its bearings, and all the straight parts, and then at the very end, there's just this tapered end that fits it all together. Now it's kind of a nice idea because assuming that the shaft and all the straight parts are straight and all the bearings are nice and square, having this taper and having a matching taper inside here means that when they meet together, they should be concentric, fairly concentric, which means that your drill bits, assuming that this holds them straight, you'll get a straight line between your drill bit, your taper, your spindle, and the whole drivetrain of the thing. Now obviously for one of these cheapo drill presses, you can't rely on any of that being super precise, but it's still the same. This is done, the Morse tapers like this are common in even more upmarket machines as well. So yeah, it's just kind of an interesting fixture, and the way you put them in, which might seem a bit bonkers, is you just slot it together like this, make sure it's on, and you just push it. You just push down on it. Now you can see there's some flex in this. This isn't the strongest thing in the world, so you can push up on the bottom, you just push into it, there you go, little crack and stuff, and that's in place ostensibly. yeah, so that's kind of it. Now, the other thing about this, what is interesting about this design is that the more force you put onto it, the more work that this does, the more it's going to want to, you know, push up, because there's that compressive force the whole time, so it'll want to make itself tighter. You will see though with these that if you can sometimes get like a really bad, you know, catch on something, and these can actually, they can pop off. You can get enough force that they can pop off. Now this machine will it'll more than likely stall out. The motor will more than likely stall before it manages to drive that off. But yeah, that's something you can see with them as well. Okay, back to the assembly. And there we have the drill press in its final resting place. Went together pretty easily. Yeah, pretty straightforward. I like this little thing. Took me a second to figure out how it works. A little depth indicator. That's a nice little feature. God knows how accurate it is, but hey, it's there. And the protective cover guard yoke, which I put on backwards. You might see in the time lapse. I had to take the chuck back off again to then put that guy on. So I thought this is a little relief clip in here that you can unscrew. Thought it would work, didn't. Anyway, there we have it. That's it. Now I just got to use it for something. The first part of this build is going to be the frame, which we're going to make out of this extruded aluminium. So the first thing we need to do with this is, you can see here, the extruded aluminium has some 4mm holes through the middle of it. So the first thing we're going to do is we're going to bore those out to about 4.2mm, which is the tapping drill size for an M5, so that we can put M5 screw threads in there. And the idea of that is then that we're going to drill through the sides of our extrusion here, and we're going to suck in some M5 screws on either end to hold the whole frame together. So this is the rough idea of what the frame is going to look like. Something like this anyway. It's going to be a rectangle about 50mm wide, or sorry, 50 centimeters wide, 500mm, and about 400 deep. And so another piece of the extrusion like this will ride back and forth like that, which will give you your X and Y axes for the CNC machine. So the first thing I need to do that is I need to cut this down to length, because these are all 500mm pieces. I don't need that length, so I need to cut them down to length, and I'm going to do some test drilling and tapping on these ends just to make sure that that it's all going to work right. Alright, I'm going to get to it. So these are the final parts of our test piece. So it turned out pretty well. I was experimenting with a few different things there. Firstly, cutting the extrusion on the miter saw, which actually gave a really nice cut. I'd seen this done, but never actually done it. And yeah, it gave a pretty nice clean cut. The edges are all pretty smooth. I might go over them with the deburring tool or a small file, but yeah, they're in general pretty good. I bored out the center bore on this one to the tapping drill size, and just tested tapping some threads into that, M5 threads, and they fit pretty nicely. So that's a nice good clean thread in there. Now the part you might have seen that was a bit weird that I didn't talk about before was these V-grooves. They won't fit the cap of a socket head cap screw, M5 socket head cap screw in them. See, they're just slightly too wide. I think the gap here is 6mm, and I think the head is diameter of 8mm or so, so it just won't really fit properly at all. And because of the way I plan to join these together, there will be a socket head cap screw essentially screwing through like that, and I'd like it to sit flush there, but I can't do that without modifying this. So what I did, which was horrific, and I hope to figure out a better way to do it, was I took this large 10mm drill bit and just very gently introduced it in here so that it would just carve out a little gap here for me, and then lined up in the same setting, I just center punched and drilled a 5mm hole through. So that is essentially how it will go together, not quite in this orientation, but basically there'll be a small relief done in there. I might figure out a better way of doing that yet, but that is kind of it for now. It'll go through there, and then it'll go through and tap into a thread on the other piece. So I'm reasonably happy with this experiment. Might refine some of it, but I think the next step is to cut all the pieces to their final lengths and then drill and tap them and assemble them and just see how that goes. So we have the main parts for our body all drilled, tapped, cut to length, and ready for assembly. I'm pretty happy with how this went. I'm surprised it went as smoothly as it did. I did find a better way to cut these little reliefs that you see for the head of the socket head caps. So before I had done just a 10mm drill bit and tried to, center it up and get it to cut out those reliefs, and it was really messy. This time, instead what I did was I pre-drilled the center holes for 5mm, and then I got a step drill bit that was going up in increments of 2mm, so I had a 4mm hole that I could center reasonably well in that, or 4mm tip to it that I could center reasonably well in that, and then I could just bring that down slowly, lots of oil, cutting oil on that, and bring it up to the 10mm just around the outside, and then that just nicely fits the socket head cap screw there. It's just so that's nice. All right, now I'm going to assemble. And there we have it. The frame is assembled, at least the bottom part of the frame anyway, and that went together really well. I'm very impressed with that. Everything seems to line up nicely. There's, yeah, it's all pretty good. My bench here isn't flat, so I'm fairly certain this is more square than this is level, so that's a good sign. Check on with the square. Yeah, not perfect, but pretty damn good, I think. Yeah, so that is a result. Very happy with that. So yeah, so this is basically what the structure is going to look like when it's done. Something like this. Move back and forth. You're going to have linear rail along here. It's going to be a piece that comes up, attaches to either side. I'll move back and forth, and that'll be the motion of the gantry, and then another rail across here, which the spindle can move along. All right. Nice. All right, we are back in the workshop. It's been a little while, and for me it's been a little while. For you it's been mere seconds, but yeah, we've made some good progress here. The linear rails arrived, which we're going to be on either side to actuate the gantry. Printed out some gantry supports and some end stops, and we have a little moving gantry, which is pretty smooth. And these are far from first prints. These are some old ones, and these guys are the latest incarnation, and there's an even newer version of them currently cooking on the 3D printer. So a lot of work still to be done to get this frame. It's still kind of this bit of racking here, which you can see, because some of the thicknesses here aren't quite right, so the fixings aren't, they're not like really solid. Also, this rail is not actually mounted to anything. It's currently just pinched between these end stops. So today's job is to fix this rail onto the V-groove aluminium so that it's nice and solid. So I have to get this nice and level, and then drill and tap a whole bunch of holes, and then fit them all with little M3 screws that I have. So that is what I'm going to do now, and you guys can watch. Okay, and there we have it. This is kind of the first milestone in the project so far. We have the whole frame assembled, got nice end caps put on, we have linear rails mounted, screwed on, we have the gantry supports attached to the rails. So it works. It was pretty smooth, it was pretty light. There was a little bit of racking if you pull it from one side or the other. There is some flex there. I mean, these are only 3D printed, so there's always going to be a little bit of flex in them. This isn't quite the final version of these, or there will be another version as well, because I need to figure out how to couple a belt to this to drive it, and it'll be driving this side, so that should hopefully stop the racking from being much of a problem. And these screws will be sunk a bit deeper, so this material basically will be thicker, so the whole wall will be thicker, which will hopefully mean that won't flex as much. I may also, the final version of this, whatever it looks like, may print this with either solid or with just a very, very high infill. This is only 20% infill at the moment, so it's not the strongest thing in the world, but I'm pretty happy with this. It moves pretty well, and you can adjust how sort of tight it is by adjusting the tension on the 4 screws on either side, which is nice, so that you can pinch it in a little tighter, and you can loosen off the tension to get it, if it's racking more, binding on one side, which is a nice level of adjustment to have, which I'm pretty happy with. So yeah, that's about it for the first part of the project. Next thing that I'm going to have to do, I need to order some parts. This is probably going to take a while. I have to get some motors, I need to get some belts and some pulleys, and have to figure out how to mount all that, so there'll be a lot more 3D printed parts, and yeah, just a lot of thinking and design work for the next while. So I hope you've enjoyed watching me build and assemble this frame. Yeah, so stay tuned for the next one. Hey guys, I hope you liked this video. This is the first in the series that I'm doing on this project, which I'm going to be continuing to work on over the next while. So if you want to see more about this, you can subscribe to the channel, like, share the video, and if you want to support the work I'm doing, you can find a link in the description to my Patreon. Thanks for watching.